we're reviewing how triangles are going to be similar using the shortcut side, 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 and side angle side. So the essential question is, how does side, 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 and side angle side show triangles are similar?
Wait, isn't the more arcs?
So if this is my case, I'm going to pair up, okay, 9 to 3. Is that going to reduce to the same fraction as the next two sides? And then is that going to reduce to the same fraction as the next two sides, 15 to 5? So these two triangles are similar because every single one of these fractions will reduce to 3 to 1. That's where we're at. If we just have 3 sides compared to another 3 sides, and they all reduce to the same fraction, by side, 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 we've got similar triangles. So in the second situation, we're going to see sometimes the picture may show two angles are congruent, or maybe they'll put an actual number there that is the same in both pictures. But in either case, you still got to test. Okay, is 12 to 8 going to be the same ratio as 18 to 12? These both would reduce down to a 3 to 2 relationship. With that, then we could say by side angle side, we've got similar triangles. So in problem 1, we got to do 3 things. The directions say determine whether the triangles are similar. So that's 1. We're going to say yay or nay. And then if they are, you're going to write a similarity statement. Triangle blah 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 is similar to triangle blee. And then we're going to find the scale factor, like the reduced fraction. So first off, because I see only the sides being marked, I'm going to check side, side, side relationship. We need to start matching sides to other sides. So in this case, 8 in relationship to 4, 12 in relationship to 6, 10 relationship to 5. Like, do these reduce to the same fraction? So divide the first fraction by 4, divide the second fraction by 6, divide the third fraction by 5. So reduces to a 2 to 1 ratio. So yeah, these are similar by side, side, side. There's the first answer. Then the second answer comes triangle blah 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 similar to triangle blah. So we've got triangle PQR similar to triangle STU. And now we're going to figure out the scale factor. The scale factor is going to be the reduced fraction all 3 of these fractions reduce to. So that 2 to 1 ratio is also part of the answer. 3 pieces. Yes, similarity statement, the ratio. Let's go to the next one. So we're going to compare 3 to 5 in relationship to the other 2 numbers, 6 to 10. So 3 to 5, we're asking, is it going to be the same as 6 to 10? Do they reduce to the same thing? They both reduce to 3/5. It's just the first fraction can't reduce because you're dealing with numbers that don't share a factor.
Yeah, I thought they both had to be divided.
They are similar by side angle side, so we're ready to say triangle blah is similar to triangle blah. And then we're ready for the scale factor. The scale factor is the reduced fraction. So in this next example, since I don't see any angles being marked, I'm going to have to just match up the sides. And we're going to figure out, okay, are those 2 sides equivalent to the next 2? And then is that equal to the last 2 numbers, 15 to 13? Because none of these fractions will reduce to the same thing. Well, this reduces 1 to 1, but we don't have the same fractions here. These are not similar. So this is an example of not being similar. You go through the process and recognize none of the fractions are the same. Even if 2 of the fractions were the same, if that third fraction still did not match the reduced pieces, you do not have a set of similar triangles. So let's go to these overlapping triangles. Both the smaller triangle PQR and the bigger triangle PST, they both share that angle P. So we're checking side angle side here. Going to see if these 2 triangles, the smaller and the bigger, are similar by side angle side. Compare the smaller side 3 to the bigger side. But the bigger side is from P to S. You've got to determine what is that amount. It's a 6. And then we're going to do the same thing with the other side. We're going to figure out, okay, is that relationship the same relationship as, okay, from PR being 5 to its corresponding big side. So do these fractions reduce to the same amount? They both reduce to a half, so we can say, yeah, these two triangles are similar by side angle side. Now this is a challenge problem. I'm not going to test you over an overlapping triangle, but it still exists. We're not done yet. We need to say triangle blah 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 is similar to triangle blah. And then the scale factor is 1/2, that reduced ratio.